Alright, looks like we are live. Okay, let's continue. Let me open table of content first. Okay. We are at chapter 5 on section homework code here. So let me open this. We are in this section homework code. Here they try this access variable from a parent and chat process. Open a file from parent and chat process. But yeah, currently I'm still not sure about this. Writing to the file at the same time from parent and chat process. I assume. Yeah, I'm still not sure about this. So we move on into the third question, which is to ensure that the chat process always print first without calling with or with PIT system call. So let me open that. I've already tried a few solutions. The first one is using select to block the parent process according to the timeout. In this case, 10 seconds. And then when we got the child signal here, we execute the signal handler here. What is it called? It is basically print out a message goodbye. So I'm using the signal system call to print out in the parent process here. Goodbye. And then if we take a look at the signal system call here, there's a warning that the signal varies across Unix version and Linux version. So avoid its use and use seek action instead. Okay, so that is the second solution. Instead of using signal system call, we are using seek action. It is basically the same, but I also try using the signal max to ignore specific signal. So like this. Wait a minute. When we press Ctrl C, it's equivalent to signal interrupt. When we are inside the signal handler here, it is sleep. I add sleep for 5 seconds, right? We will ignore the signal, and then after we finish, what is it called? We finish executing the signal handler. We evaluate those signal interrupt, which result in exit code 130. That is okay. That is a second solution. And then there is a third solution, which is using seek wait. So rather than register the signal handler asynchronously, we are waiting the signal synchronously using SIGWait. But the interesting part about this is that we need to make sure that the signal is blocked or in the pending state. If we take a look in the main page here, where is it? The description is SIGWait suspend execution of calling thread until one of the signals specified in the signal set becomes pending. So if we didn't make the signal pending, the SIGWait will indefinitely waiting for the signal, because there is no timeout here, and that is why we use SIGBlock max to change the signal set we provide here with eSIGChild, right, to the pending state, so that we can catch that with SIGWait. So let me demo that. Okay, something like this. But if we didn't block the signal or making that into the pending state, let me try compiling that. The SIGWait will wait indefinitely like this, because there is no timeout. Oh, it's quite cold. Alright. That is the third solution, and for the fourth solution, I'm trying out save pipe trick. Let me change that. Because I want to, what is it called? I want to split, I guess, because previously because when I tried Looks like we can do that without pull to wait the file descriptor to be ready. Can just use read. But yeah, the second part of this I'm trying to use pull. Okay, let me go for a bit. Be right back. Alright. I'm not sure if there is any guarantee that read will wait the chat process, I guess. So yeah, let's split this one file to use without pull and another file using pull. Oh, and also I found, what is it called? No, not this one. This one, I guess. So I'm kind of curious, right? How to handle when the write system call fail to write to the pipe file descriptor. So it looks like we can just close the read end of the right end of the pipe, and it will give us an of file. Let me demo that, I guess. Something like this. What is it called? Self pipe 1. Okay, read end of file, right? So maybe we can do that. But yeah. I mean, at the end we close the pipe, right? So error, okay. Yeah. Should I add close pipe in this one too? Well, maybe. Okay. And then we handle that in here. If, what is it called? If it is an off. What is it called? An off file, right? And return like this. Immediately return. Is it going to be okay if we immediately return without closing the pipe? Or we need to close the pipe first before reading that? Something like this. Let me try. Okay. Lead pipe error success. Yeah, I just want to try that. So yeah, maybe after read the pipe, the read end of the pipe, just close it immediately and then evaluate the, what is it called? Evaluate the return value. That process, but there is goodbye. And the next thing, what happened? That is unexpected, I guess. Wait, they already closed that, right? Return. That process flight error. Okay. Let me try. Check that. Return code read. Long in. Okay. Okay. Let's try something like this. Yeah, there is no file descriptor 16.9. Okay. But file descriptor read and of file. Maybe something like this. That I think that kind of make me curious. Okay, maybe something like this. And a file. Okay. Alright. Yeah, that kind of make me wonder. Can we use assert in the chat process? Or what happened when we use assert? Okay, the return is void. Alright, expression. Let me check. On success, the number of bytes written. On error, negative 1. Okay. Alright. If expression is false, assert print an error message, or if it is false, equal to 0. Okay. So maybe we should do something like this. Okay, right. Let me check. And if we fail, okay. Assertion. But here there is no. What is it called? Okay. There is no error. the customer message just fill like this, and yeah, we didn't get the exit code right, so let's just use something like this, or maybe should we use code to okay. Okay, let me try this one. And then I also found about at exit, which is register a function when we call exit or return in the main function. If I understand correctly, yeah, something like this. Let me copy this to the check in case anyone wants to take a look. Cut after exit, and therefore triggering the function register with at exit. Sectum. That finish being handled by a function register with some situation. After a sec for register a function to be called at normal process termination. Via return from programs main. Okay. It is inherit copies of its parent registration. Even a successful call to one of the exec function or registration. All registration are removed. It returns on a non-zero value. Okay. And exit. Maybe let's try at exit on the next. What is it called? On the next file, when we try using pull here. We put this in here. Okay. No, not that one. The pipe and right to right and off the pipe and or something like that. Let me create another file. Okay, something like this. This one. Okay, something like this. Let me put this in here. Using set signal. Yes, we give the set signal from the pipe. Using rise. I kind of forgot about that. Send a signal to the caller. Calling process or thread. Only after the signal handler has returned. Send a signal to the calling process or thread. A single thread program it is equivalent. What code is this? What do you mean? What code is this? If you mean what I'm trying to do, is that I'm trying to ensure that chat process always print first without calling with or with PID system call in the parent process. Is it Java? Oh, it is C. C programming language. Yeah, I'm using C currently. Wait, let me check this. I'm not sure if you can use race. Yeah, maybe not. Okay, something like this. Oh, I mean, C is simple, I guess, but that's what make it hard. So, yeah, sometimes something simple can be hard to use. So yeah, we need to do a lot of things manually. Okay, hello signal. Okay, is there any to do in here? No. Okay. Alright. Says return. Okay. Yeah, let me commit this first. Right, this is what we want to achieve. Make sure that the chat print hello first, and then the parent process print goodbye. Okay, let me think this one, right? Right, signal. Signal. Is it from the read? Kind of forgot. Read from UniSDT. So let me try removing the signal header here. Okay, it is for the SIG type. Right. Okay, let me commit that. After 5. An error. Okay. Copy that first. Example. Sample. Sample using Saint Patrick. Take to pass the signal from child process to parent process. Signal SIG chat from parent process from chat process to parent process. Was it did not specify? Okay, again, we can take a look at the seek action here. Where is it? I think this one. POSIX leave it unspecified whether seek child signal is generated when a child process terminates. Oh, okay. POSIX did not specify. After we break from the switch case, right, we are immediately going to return. So, okay, did not specify that sync child signal is generated when a child process terminated minute. So and that's why let's try passing the child signal with the self metric. Manually with self metric. The signal manually. Make sure that the parent process got the child signal. Regardless of the operating system. Operating system implementation. I think to ensure is the word here. Let me check. Ensure. Ensure that the parent process got. Okay. Currently still not sure if we need photo with the descriptor come ready. Because only using file ID. ID ensure that chat process print its content first before the parent process. So in this example, we omit the pull and only using read in the parent process. On the next example, let's see how it goes. Let's go into the, what is it called? The second example. We're using an exit and with item time out. It's an example. Okay. Okay, well, first thing first. Let me do this. And then F5, FT, and then if the return value is -1, this, okay, and of course don't forget to fork that. I think we should close first before doing anything. Maybe I should grab an exit. My stomachs. Okay. We have what is it called? The parameter is function pointer that have the return void, the return type void, and the parameter type void. Okay. is it? Save child. Exit, maybe something like this. And then we put that in here. Void. Okay, something like this, but we didn't really return anything, I guess. Maybe we can use Koto in this case. Or maybe or maybe we do something like this. Yeah, I'm kind of curious. Wait. Almost negative one. Yeah, maybe we can do something like this. So let's say if the right is fail, we will close it anyway. But yeah, I'm not sure if that gonna work or not. So let's add exit. Okay. Alright. That exit. Let me try compiling that. Yes, we need signal and then fork. Can you fork NSTT? Okay. undeclare. Now it is undeclare. Yeah, we didn't get that. So do we use static storage or static variable? Maybe yeah, something like this. Maybe I am not sure if we can combine this like this. Let's find out. Okay. Nope. I don't think we can do this. Undeclare. Okay, let me check. Yeah. Do we need to make this global? I don't really want to. If I can. Using static in here. Can I want to try this. If we put this in here, like, okay. Should I use a global? Global variable. But yeah, is static, what is it called? Combine with this type or per variable? Yeah, I'm not really sure. I mean, if we are using static, we are gonna have those default value, right? Okay. Maybe something like this. And then default. Equals this. Right, let me add this first before I try to modify that. Okay. file descriptor. Okay. Alright. Using alarm. Yeah, should we use volatile? Okay, and exit right top pipe. Now this is interesting. Again, is this in the same main function? Oh, okay, global for exit at exit handler. Maybe I should put this before this one. These two global static for exit handler, something like this. Yeah, I'm not sure if you combine this like if you combine the static in like this, are we gonna is the static in also gonna be in the signal or not? Yeah, I'm still not sure about that. Maybe we can check that out. Static declaration. Multiple static declaration in one line. No, not that one. I mean, if the static Well, for readability, let's just do this in different lines. Right. Okay. Time out for select. Okay. Read FT. Read FT. Okay. Instead of using select, I make one to try using pull. But yeah, it is still using with PIT. Close the pipe, the red end of the pipe. Okay. Read. Now terminate the buffer manually in this example. Right size of buff -1. So what is it called? We save the one character for the null terminator to add manually null terminator here, and then we close the read end of the pipe. Okay. In this example, parent writes to the pipe, so close unused read end of the pipe. Okay, and then close. Wait for the chat to finish. Okay. Right. Right. Is there an example? Yeah, there's a full example here. Where is it? Let me check this. See, self pipe trick. That the event loop still on read. Oh. Okay. Now let me put this in the description too. In addition to the pipe, this one using weight. Oh, right. So if you static in here, okay, and this is expected. Handle that output. Status. In the parent, a specific mechanism. Again, do we need to use iteration when using pull? I'm not sure. Let me check. Okay, the Linux specific. Okay, where is it? This one. We need pull header. Okay. Buffer descriptor. Initialize state. The pull that become ready. I think it should be the red end of the pipe. So something like this. And what is the event? Requested event. Okay. An event that can be written. Okay, this is the event that are defined. Polling. There is some exceptional condition on the file descriptor. Possibilities include dash out of band data. Okay. Should the terminal master in packet mode has seen a state change on the sleeve. Okay. A C group event file has been modified. Yet I'm reading this previously. That is... Yeah, I'm still not sure about that. C group event file has been modified. Writing is now possible to write larger than the available space in a socket or pipe will still block. Okay. Since Linux 2.6.17. Stream socket, peer close connection or shutdown writing half off connection. Okay, pull error condition. Only return in even, ignore in even. Okay. This bit is also set for a file descriptor referring to the read end of a pipe when the read end has been closed. Pull it up, hang up, only return in even, ignore in even. Note that when reading from a channel such as a pipe or a stream socket, this event merely indicates that the peer closed its end of the channel. Close its end of the channel. Subsequent reads from the channel will return 0 and a file only after all outstanding data in the channel has been consumed. Pull it up. Okay. Invalid request FT not open. Okay. That is data to read. I'm kind of curious. Can we do this? So we take clear first and then assign the array element of the struct. Okay. But wait a minute. I think I've tried that. Yeah, I kind of forgot. Only this one, huh? C programming assign array element of struct. And this is we initialize, right? Okay. Yeah, this is the usual initialize array. I mean, I know that we can do something like this, at least, right? Only unused variable. Structure assignment operating on a structure type copies the structure. Struct point error. Assignment expression. Okay, oh. Again, this is what I do here. But do we need to use iteration? Do we need to use iteration too? This is the initialization. Maybe let's just initialize this. Exit. Using signal. Oh, read FT. Polling. Wait a minute. Is an input parameter bitmark specifying the events the application is interested in for the file descriptor. Oh, for the file descriptor. Okay, so maybe rather than the read n, we should use the read n of the pipe. Let me copy this in the chat. Is anyone who wants to take a look? And let me change this to this. Put them on without any signal. Save and restore no. Handle error. Oh, this one. Okay. Read FT. Yeah, this one. Handle signal. Okay. Oh, the exact byte, I assume. Okay. But here, path, this one. If it is not exactly one, throw an error. But when we write, is this it? FCTNTL. Okay. Manipulate file descriptor. Oh. Perform one of the operations described below on the open file descriptor. The operation is determined by OP. Certain of the operation below us. Okay, I think it is in the POSIX standard too. Okay. Certain of the operation below support only since a particular Linux kernel version. So there are some operations that are not supported on the older Linux kernel version. Just something to keep in mind. Whether to set OP value and then test whether the call file with an invalid value, I assume. Indicating that the kernel does not recognize this value. Okay. The value depends on the operation. But yeah, what? What is this too? Let me check. CNTL. To modify the flag and set them with not that one. close this. Okay. Its antipodictive intense on open descriptor, changing the attribute of a file. Oh, changing the file descriptor itself, I assume. And wait, not this one. Various control operation on open file descriptor. Okay. On an open file descriptor. Yeah, I'm still not sure what FCNTL do. And what this do? Set file descriptor, I assume. Oh, wait a minute. Set FD. The flag associated with a file descriptor. Currently only one such flag is defined. FD exec, the class on exec flag. Yeah, I'm not sure why we need to do this. And again, when double FD gonna be ready, you know. Let me check. Okay. Even that is data to read. return a non-negative value, which is the number of elements in the pool FT whose R event field have been set to a non-zero value, getting an even or an error. A return value of 0 indicates that the system called timeout before any file descriptor become ready. An error negative 1 is returned. Okay. Integer, right? Okay. Pool FT, and then NFT. What is NFT? The colors specify the number of items in the FT array in NFT. Oh, the number of items. Okay, so because we use array, right? This one, maybe we should find a macro array length again. Size of array, something like this. Array length, pool FT, and then the timeout. Millisecond, okay. Let's try 1000 millisecond here. An error negative 1, okay. Simple call negative 1. Error return, okay. If it is 0, indicates the system call timeout, okay. Parent process call timeout. Return 42 mapping. The number of elements in the pool FT. Okay. And the signal. Where is it? of element, right? And let me put this here too. Where is it? Signal FT. Oh, okay. Iterate end of the pipe. Okay. And then oh, in this example using signal to register a signal action for interrupt. Okay. Oh. Alright. Writing to the red end of the pipe. Okay. Is it still? Yeah, it is still in the for loop. Okay. Return a non-negative value, which is the number of elements FT whose even fit have been set to a non-zero value. Maybe we need to check the return event. And let me put to here. Check the fans from the pool and then exit the loop. If the add even effect, if the add even expected, the add even. Okay, let's try this on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.